Okay. All right, we left off. We were talking about how to name chemical compounds. So we know for things that are ionic, we don't ever say how many things we have in the compound. If it's covalent, we do. So that's why we have to distinguish between things that are ionic and things that are covalent. And who remembers how we could do that? How can I distinguish between those two things? Okay, if it has a metal in the compound, it's ionic. Okay, that's the first way. The second way is if you have more than two elements in the compound. If you have three, that means there must be a polyatomic ion, which means your compound is ionic. Okay, so that's the second way. Because there can be some that are kind of tricky, like ammonia. This is NH4. Ammonium, I should say. Ammonium carbonate. NH4CO3. That is ionic. It's an ionic compound. Even though it starts with nitrogen, which is a nonmetal, okay? This is pretty much the only exception you're going to see to that metal idea. If you see a metal, it's ionic, okay? If you see a nonmetal, probably 99% of the time, it's going to be covalent, except when you have a polyatomic ion like ammonium. Other than that, you're safe, okay? So metal, ionic. Non-metal, covalent, with that exception. Now, we talked about the transition metals. They have multiple charges. So, when I name something from a transition metal, I have to state the charge of that metal. So here's a few examples. FeCl3. So I know the charge of this iron is +3 from the compound. How can I determine that to be +3 from this chemical formula? What's telling me that that iron has a 3 positive charge? The chlorine. Chlorine has what charge? -1. So if I have 3 -1 charges that have to be balanced by 1 iron, that means the charge on the iron must be what? 3+. Okay? Now, I could have done switchy thing, right? Switch up, switch up. Cl has -1, iron has +3. It works. Does switchy thing up always work? No, you have to be careful. Okay? It works here, but sometimes it doesn't. And we'll look at a few examples of that. Like this one, it doesn't work here. Okay, but it does here. So if you have 2 subscripts, you can always be certain that switching those will work. But if there is only 1 subscript or no subscripts, then you have to determine the charges from the elements that are there. So this is iron 3. What does that 3 represent? Does it represent the number of irons? No. What does it represent? The charge. Because what do I know about ionic compounds? You never tell me how many there are. This iron 3 does not stand for having 3 irons. It stands for the charge. Because if I know the charges, Fe3+ and it's not oxygen, it's chlorine, and Cl-, I can determine the formula from the charges. So that's all I need to know. FeCl3. Okay? So you never tell me how many there are in ionic compounds. In covalent compounds, you do. Okay, let's look at these other 2 examples. This is iron 2 because this iron has a 2 positive charge on it. This is copper 2. What does that 2 represent? The charge on the copper. This is copper 2 plus. What is the charge on this oxygen? That's right. 2 minus. Okay, here's oxygen. -2. Well, that makes sense because I only have 1 oxygen. That means this copper must have a 2 positive charge on it to balance that, to balance it. Okay. Okay. Don't worry about ick or us. I'm not going to require you to know those. Okay. Like this would be ferrous chloride or ferric chloride depending on the charge that it has. Don't worry about that. Okay. But this is more what I want you to learn. Okay. How to name them using their Roman numeral. Iron 2, iron 3, copper 1, copper 2. And it all depends on the charge that it is associated with. Okay? So, what are the names of these 3 iron oxide compounds? What's the name of the first one? Good. This one is iron 2 oxide. Why? What does the 2 represent? The charge. This has a 2 positive charge, right? What is the charge on the oxygen? 2 minus. That's how I knew this was iron 2, because they have to balance. Okay? What's the name of the next one? Okay, we're going to figure out what is basically what I want to know is what is the charge of this iron, because these are all called iron oxide. But I have to state the charge of the iron. What is the charge of the iron on this one? Iron 3. How do you know? It does have to balance out. What is the charge of one single oxygen? -2. There are 3 of them. That means I have how many negative charges? -6. So I have to balance the -6 charges of the oxygens with 6 positive charges from the iron. But there's 2 irons, so that means what is the charge on each individual iron? 6 divided by 2 plus 3. This is iron 3. Now, I didn't have to do that whole process that I just did because why? Because a switchy thingy, right? Boom. How do I know it's going to work? There's 2 subscripts. If there's 2 subscripts, I know I can switch them back up. Okay? So, iron 3. This one is iron 3 oxide. So what do you think the name of that last one is? What is it? It's not iron 2. Look where iron 2 is. We already did that one. Iron 1. Why is it iron 1? That's right. I have to have 2 irons to balance 1 oxygen, and 1 oxygen has a -2 charge. That means the ions have to give a positive 2 charge. If I divide positive 2 by 2, I get 1. That means there's a 1 positive charge on each iron to balance the negative 2 charge on this oxygen. I could have switched and it would have worked. Okay? In that case, but it doesn't always work. You have to be careful when there's not 2 subscripts. But it did work there. Okay? Iron 1 oxide. Iron 1 oxide. Okay? Try this one. What's the name of this? Mn is manganese. Manganese blank oxide. That's what it is. Okay, so it's manganese 4 oxide. How do I figure out that that's a 4? Well, each oxygen has a negative 2, right? Negative 2, but there's 2 of them. So how many negative charges do I have overall? I have negative 4. That means this manganese must have what charge? Positive 4 to balance it. Has to have a positive 4 to balance it. Okay? Therefore, the name of this is manganese 4 oxide. Okay? Manganese 4 oxide. All right. Did switchy thing work there? So you see, you have to be careful. It didn't work. Does it always work going forwards? Yes. Well, let's see. Manganese 4 oxide, if I was going to write the formula for it, I'd say Mn4 plus and O2 minus. I switch those, Mn2, O4. But what's wrong? It's not in its lowest ratio form, so I have to write it MnO2. Okay? So this is the formula for manganese 4 oxide. All right. Okay, so this is kind of a worthless slide. These are some cations. You know that from your periodic table. H plus, Li plus, these are some metals. Anions, F minus, Cl minus, Br minus, etc. Okay, we can determine those from the periodic table. Polyatomic ions. Okay, so what are polyatomic ions? Polyatomic ions are compounds that are covalent, but in their covalent structures they have gained or lost electrons. So this one has lost electrons. This one has gained 2 electrons. Okay? So because they have lost or gained actual entire electrons, they have become ionic. And they can bond with metals or nonmetals that are also ionic. Okay? So for example, this sulfate ion. If I want to bind something to that, magnesium SO4. Magnesium has a 2 plus. This has a 2 negative charge for the sulfate. So they can bond. They can bond together. If I wanted to put potassium with sulfate, K2SO4, because this has a 2 negative and each potassium has a plus 1. So plus 1 times 2 would be the 2 plus. That would balance the sulfate, K2SO4. Okay? Ca3PO4 2. calcium phosphate. PO4 has a -3 charge. Calcium has a 2+ charge. So switchy thing, I get this formula. Calcium 3, PO4s 2 of them. You see how I put it in brackets? You have to put it in brackets. Put it in brackets and tell me how many. This is its own thing. It's one thing. Even though it's 2 elements, it's one entire thing. It stays together. Okay? And you're going to need 3 calciums and 2 phosphates to create that compound. So this is how you're going to use these polyatomic ions. The polyatomic ions are already named. There is going to be a chart of polyatomic ions. It's found in your book. You'll have the same chart on your test. So you don't have to try to remember the name of PO4, 3-. It's phosphate. You go look it up in the chart and you see it's called phosphate. Oh, so what's the name of this? Calcium phosphate. You just have to tell me what there is. You never have to tell me how many. You don't have to tell me there's 3 calciums or 2 phosphates. I can determine that from the charges of those. Okay? So you just have to tell me what is there. Calcium phosphate. Okay? So that is different than this. This is calcium phosphate. This is calcium phosphide. Okay, a lot of people want to call this calcium phosphate. This is not calcium phosphate. This is calcium phosphide. Remember, I drop the ending of the phosphorus, and I call it "ide" when it's this kind of compound. Okay? But when there is a polyatomic ion present, you simply use the name of the polyatomic ion. Here is a polyatomic ion. Its name is bicarbonate. Calcium bicarbonate. I'm sure you've heard of sodium bicarbonate. That's the stuff you use when you bake your cookies. It's called baking soda. Okay, so calcium bicarbonate would be NaH. Okay, that's sodium bicarbonate. Sodium bicarbonate, baking soda. Okay, but this is what you have. This is what you have. So when you have a polyatomic ion, you simply use the name of it. I don't have to change it to "ide." It's already been changed. Bicarbonate. Okay? So you simply use the name that's given to you in the chart. All right, here's the chart. We can see. Okay? So we have things like hydronium. So these are kind of your cation ions. Those are basically the only cation ions you're going to see. Like I said, NH4. That's the one you got to watch out for. You're not going to see H3O plus a lot with compounds, but you will see NH4 a lot. Well, not a lot, but at times with different elements. So you need to make sure you know that that's an ion, and when you see it, you know that that compound is ionic, because anytime you have these polyatomic ions in your compound, it is ionic. So you do not say how many you have of stuff. Okay. So, nitrite, nitrate, sulfite, sulfate, hydrogen sulfate. You just simply use the name that they give you. Dihydrogen phosphate, hydrogen phosphate, phosphate, cyanide, sodium cyanide. Okay, that's an example. You just simply use the name they give you. Okay, so this is the chart you will be given on your test. You'll have these available as a reference. Okay, you simply just need to know, okay, that's how I put these together. You don't have to memorize it. All right, let's name these. Okay, write them down and then I'll put it back on the chart so you can look at it. Go ahead. NH4Cl, BaSO4, FeNO3, CuHCO3, and CaOH. Okay, so write those down and then we'll go back and name them. I feel like the AC went out. You guys feel like that? It feels hot, doesn't it? Yeah. Okay. Everybody ready? You need to wait a second longer? Okay. So here is the chart. Okay. So let's try to name these using this chart. What's going to be the name of the first one? Starts with ammonium. Ends with chloride. Ammonium chloride. Good. Okay? So that didn't start with a metal. So if you're trying to name that NH4Cl like you would a covalent compound, you'd be like nitrogen tetrahydride monochloride. Okay? That might be an answer choice, but don't choose that one because this is not covalent. It's not covalent, it's ionic. Okay? So I don't name it that way. I don't tell you how many hydrogens there are or how many chlorines there are. I simply say the names of everything. Ammonium chloride. Ammonium chloride. Okay? All right. What's the next one? Okay, Ba is barium. Barium sulfate. There you go. BaSO4, barium sulfate. Okay. So the hardest part about polyatomic ions is simply realizing that it's a polyatomic ion. Because otherwise you can see it's very simple to name. What's the next one? That's most of the name. Iron nitrate is most of the name, but what do we know about iron? What kind of metal is it? Is it found in the first two columns of the periodic table? It's a transition metal, which means what when I name it? I have to say the charge. Because if you just tell me iron nitrate, I could have that. I could have that. Whoops, that's not what I wanted. Yeah. Whoops. Or I could have that. You have to tell me which iron. This one is iron 3 because nitrate has what charge on it? You see it? -1. And I have 3 of them. So that's -3 charges. So what's the charge of the iron? +3. Okay? Iron 3 nitrate. What's the name of this one? Iron 2 nitrate. This one? Iron 1 nitrate. So you have to tell me which iron because otherwise I don't know which one you're talking about. Okay? So that's the other thing that you need to make sure you're doing with these ionic compounds. Okay, what's next? Okay, what's the next one? Okay, so you did everything right except tell me that you didn't tell me the correct charge on the copper. Okay, you do need to tell me a charge. Where's bicarbonate? You see it? Here, it's right here. What's the charge? -1. So what does that mean the charge of the copper is? 1, right? Copper 1 bicarbonate. Copper 1 bicarbonate. Because the bicarbonate ion has a 1 negative charge. Okay? That is common because, look, do you see this 3 down here? A lot of people think, oh, wait, that gets distributed, and that means I have 3 negative charges. Okay? You have to think of this as one entire, just one entity. Okay? Copper HCO3, okay, or copper X. This whole thing up here represents X, and I only have a -1 charge with it. That means that the copper has a +1 charge, because this is -1, this is +1. Okay? So if you need to simplify it into just one variable, that's fine. You can do that to help you figure out what's going on. You can do that. Okay. What's next? What's the next one? Is that all of them? Mm-hmm. Okay.
Wait, no, did we do?
Oh, calcium. We need to do this one. What is it? Yes. Okay. Where's my hydroxide? Okay, hydroxide. So calcium OH2 calcium hydroxide. Why don't I need to say calcium 2 hydroxide? Because it's not a transition metal. So I don't need to say calcium 2 hydroxide. What's going on? It closed on me. Come back. I don't have to say calcium 2 hydroxide because it is not a transition metal. So I don't have to say it. Okay? Otherwise, I do need to say it. All right. Determine the charge of each ion. So these are basically the rules they're saying. Okay. So you're determining the charge. Write the formula so that the resulting compound is neutral. Okay. Barium chloride. I know what the barium charge is. It's 2+. Chloride is -1. So I bring it together. Barium chloride. Okay. So we've kind of already gone over that. Let's try it. What is the formula for the compound sodium sulfate? What are the two things I have here? I have a sodium. What is its charge? +1. I have a sulfate. What is sulfate? Okay, sulfur is -2, or sulfite is -2, and so is sulfate. But what is the formula for sulfate? Do you see this ATE? What does that mean? Is it sulfur? ATE means polyatomic ion. It's an 8 ion. So the two endings that are ions are 8 and ite. Those are polyatomic ions, 8 and ite. So if I see 8 or ite, there's no ites here, but 8, 8, 8, then it's go to the polyatomic ion chart. If it's ide, I go right there. See, this is sulfide. This one is sulfate, SO4, and it is 2-. Okay? So I would look it up on my chart. I would find SO4 and find out that it is a 2- charge. What is the formula? Good. Na2SO4. That's the formula. That's the chemical formula. Next. What is ammonium? Ammonium is also a polyatomic ion, NH4 plus. So you find it in your chart. You find out it's NH4 plus. What is this? Sulfide? Sulfur with a 2 minus charge. What is the formula? How many ammoniums do I need? I have a plus, no, I need more than one. I have a +1 charge and I have a 2 negative charge. I need 2. And H4, and I need 2 of them. How many sulfurs do I need? Just 1. Ammonium sulfide, NH4 2S. Okay, that's what I need. Magnesium phosphate. Magnesium is Mg. What's the charge of a magnesium? Good. Phosphate. What does that ATE indicate? Polyatomic ion. So I go to my chart. I find it to be PO4 3 minus. What is the resulting formula of this? Okay, good. I need 3 magnesiums. How many phosphates do I need? Good. Brackets, PO4, and I need 2 of them. Okay? Chromium 2 sulfate. Chromium is Cr. What is the charge of chromium? Say it again. Okay, good. How do I know that? It says it right in the name, right? Can I determine it from the periodic table? I can't. The name tells me the charge. They have to, because otherwise I wouldn't be able to do anything with it. Cr2 plus. Sulfate. What does that indicate? ATE. Polyatomic ion. SO4, it's right up here. Sulfate, SO4, 2 minus. What is the resulting formula? CrSO4. They balance each other. So I only need 1 of each. Okay? There we go. That's how I'm going to write those formulas. Okay? Now, we're going to do covalent compounds. And you're going to be like, Mr. Crandall, this is so easy. In fact, I think you guys did this last time. Why don't we do it for everything? Okay? It would be wonderful if they did. They don't. Okay? So let's name covalent compounds using prefixes, where we do tell the reader exactly how many things we have in the compound. We say exactly how many there are. Okay? And we use these prefixes: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, deca. Okay? Those prefixes will be given to you as a reference material. You don't have to memorize them. You just simply need to know how to use them and when. Okay? I need to know if it's ionic or covalent, because when it's covalent, I use these. When it's ionic, I don't, because you never tell me how many you have if it's ionic. You only tell me how many you have if it's covalent. Okay? And that is because you can have some covalent molecules with the exact same elements that have different numbers of each. And if that's the case, I need to know which one you're working with, because it's not coming together as ions, it's sharing of electrons, and they can share it in multiple ways. Okay? So we use these to do it like this. Okay? I would name those two different. I would name them differently because there's different amounts in each one. Phosphorus trichloride, phosphorus pentachloride. You notice how I didn't say monophosphorus? I don't say monophosphorus if it's the first element. Now, if it's the second element, I do say mono. Carbon monoxide. Carbon monoxide. So for the second element, I do use the prefix mono, but for the first one, I don't. Okay? Dicarbon dihydride. Now, do you notice that I'm still using the IDE ending? You still do that. Oxide, chloride. Okay? You still use the IDE ending. Hydride. Okay? Hydride. What's the name of that? You guys are like, I know the name of that, Mr. Crandall, but now I don't want to tell you because you just told me something else. Dihydrogen monoxide. Dihydrogen monoxide. Okay? So if ever somebody's trying to sell you dihydrogen monoxide, okay, because it's the greatest thing on earth, which it is, you know it's just water. People have tried that. You know, they're like trying to market water as something as dihydrogen monoxide, and they're like, it's just the greatest thing. You need some dihydrogen monoxide. Okay, so don't fall for it. It's just water. All right. Okay, so we've already gone through that. Let's name these. What's the name of this? Say it loud. I think somebody was saying it. Silicon dioxide. Okay, what's the name of number 2? Dinitrogen pentaoxide or pentoxide. Okay, how about the next one? Carbon tetra chloride. Good. Iodine hepta heptafluoride. Okay, that's all there is to naming covalent compounds. That's it. That's all you have to do. You just simply have to say how many there are of everything. And that's so easy. You want to do it for everything, but you can't. You cannot use this system for ionic compounds, because with ionic compounds, you can determine the formula from the charges. You don't need to tell me how many there are. I can figure that out. But with these guys, you have to, because I could have maybe 1 nitrogen and 4 oxygens. A covalent compound with that. And that would be a different name than this one, which is dinitrogen pentoxide. Okay? So you have to tell me how many there are in covalent, not in ionic. Okay? All right. So here's a few examples. Nitrogen trichloride, diphosphorus pentoxide. Okay, and here's some examples of some commonly named things like water, ammonia, ethyl or ethyl alcohol, glucose. You would never have to tell me the name of this, other than that it's glucose. Well, you won't even have to tell me it's glucose, but because I'm just going to require you to look at binary compounds, not things with more. So remember, if there's 3 things in that compound, what do you know about it? You know it's a polyatomic ion. Okay? This is not a polyatomic ion, but I wouldn't give this to you. Okay? That's why you can be certain if you're on a test and there's more than 3 elements in your compound, you know there must be a polyatomic ion. It must be ionic. I'm going to have to find that polyatomic ion in the chart. Okay? Okay. Let me see. Okay, what are the formulas for these? What's the formula for that first one? How many nitrogens? NO. Nitrogen monoxide. Okay, what's the formula for number 2? N2O4. 5 would be penta, and you'll have that reference material. You guys don't need to memorize it, but tetra is 4. What's this one? P2O5. What's the next one? F3, trifluoride. Okay? That's it. Okay? It takes very little to learn how to name those. Okay? Okay, we're not going to get there quite yet. Okay. I will be right back because I'm going to go grab